Right, so we're going to start analyzing the graphs of functions. And so a graph of a function is just the collection of all the ordered pairs such that x is in the domain of f. And we start getting higher in your level of mathematics. A lot of times for y, we just represent it, if it's a function, using f of x. So the ordered pairs, the first coordinate is x, the second coordinate would be f of x, or the y coordinate. All right, so for the first example, we're going to use the graph of the function to find the domain and range of f, and then we're going to find some indicated function values. So let's just start with the domain and range. All right, so don't forget the domain is all the x values for which the function is defined. And so the graph is always where the function is defined. And so we look at the left. If you look on the left, there's an arrow that's going to the left forever and ever. So that arrow is going towards negative infinity. And then if we look on the right, there's an arrow going forever and ever to the right. So that is also going forever to the right is positive infinity. So you can represent that. So arrow going left, arrow going right means all real numbers. If you would prefer to represent all real numbers with that fancy R, that is also okay. Now the range is all about the y. So when I find the range from looking at a graph, I start at the bottom and work my way up. So I look to see if there is the lowest point of the graph, and there is. It's this point right here. So what we want is the y value at that point, and the y value at that point is -4. All right, and unless there's some kind of weird hole in the graph, which I don't think there will be because we haven't even talked about that yet, there would be a bracket to include that -4. All right, so then we move up, and then you try to see, is there a highest point on the graph? Now, because this graph keeps on going up, up, up forever, there is no highest point, so the graph is going to go all the way to infinity. And don't forget, on interval notation, you always use a parenthesis on the infinity. All right, so let's find some values of the function. Now, I know in Algebra 2, you guys did the graph for the domain and range of that first part. I don't think that you used a function to evaluate certain values. So it's new, so it's fine. It's not hard. You'll be fine. All right, so for A, we want to find f of -2, the value of the function when x is -2. So first, we'll find where on the function x is -2. So that would be that point right there. So when x is -2, the function is equal to 0. All right, for B, we're finding f of -1. All right, so we'll go on the function, find where x is -1, which would be right here. We drop down to the actual function. All right. So we're looking at this point right here. So I would say the value of the function when x is -1 is -2. Now, it's kind of hard to tell because there's not a grid. So if I put one of these on a quiz or a test, I would definitely have a grid where you could see exactly where it is. You wouldn't have to guess, it's between -1 and -2. You would know exactly where it was. All right, so what I want you guys to do on your own is do C and D, please. right, so f of 1/2 is easier to do than some of them because you can really tell that that's going to be where the function is equal to 0. F of 1 is slightly more difficult. So x is 1 here, so I'll go straight down. So that looks like about -2 also, this point right here. But again, it's kind of hard to tell on this because there's no grid. All right, so let's go on to determining from a graph whether a relation is a function. And we already talked about this maybe last week. This is going to be the vertical line test. That's what we're going to use. Okay, so when we look at A, we see if there would be a vertical line that would ever cross the graph at more than one place. And there isn't. And like you can look at the grid here, never crosses at more than one place. So that would mean yes, this is a function. And then when we look at B, obviously this fails the vertical line test. So if I drew a vertical line, it definitely crosses at 2 places. So this one would be no, this is not a function. Okay, one thing that is really important parts of a function are the zeros. So any function that represents some kind of real life situation, the zeros are like where important things happen. So finding the zeros of a function is something we'll do quite a bit. And the zeros of a function are the x values that make the function equal to 0. So we've already done this. We haven't necessarily called it finding zeros, but if we're finding a zero of a function, we set the function equal to 0 and then do whatever we have to do to solve it. So for this quadratic equation, to solve it, we're going to factor. And it looks like it might be a difficult problem to factor because we have a 3 there, but the only way to get 3x squared is 3x and x. The only way to get 7 is 7 and 1. So we just have to figure out where to put the 7 and where to put the 1, so we end up with 4x. And so this is how we would factor it. And then if these are linear factors, it's not difficult to look at the equation or look at the factored form and find the 0. We just do the opposite of this number divided by this number. So -7/3. We do the same thing on the second factor, but we don't have to divide by anything because the coefficient is 1. We just do the opposite. Okay, so we've had lots of practice so far this year solving equations. That's not really going to go away. All right, on B, it's a little different. So we're going to take this equation and set it equal to 0. All right, now to solve it, if there's something in the denominator that we don't want, we always just multiply by that denominator. But when I multiply 0 by 3x, it just becomes 0. So on these rational functions, if you want to find the zeros, it's really just the numerator set equal to 0. All right, then we'll just factor it again. And we get 2 zeros, 5 and 4. And then since this was a rational function, we probably would want to check real quick to make sure neither one of those give you 0 in the denominator. And they don't, so we're good. Okay, let's talk about increasing and decreasing functions, or intervals. Now, I know that you guys learned this last year. Hopefully you remember. So if a graph is falling, it's considered to be decreasing. So you always read a graph from left to right. So anytime the graph, as you're reading it from left to right, or I like to think of like you're walking on it from left to right, if you're walking downhill, the function is decreasing. Anytime that you're walking on flat ground, the function is constant. And then anytime that you're walking uphill, the function is increasing. So, and you're always, remember, always going from left to right when you're reading a function, just like you read words. So on this blanks to fill in, so for this particular function, the graph falls from where x is -2 to where x is 0. Right? This particular graph is constant from where x is 0 to where x is 2. And this is rising or increasing from where x is 2 to where x is 4. So we use that to determine intervals. And anytime you're doing this increasing and decreasing intervals, you're looking, the numbers you put in are x's. They are never y's, only x's. So you would say that this function is decreasing from -2 to 0, constant from 0 to 2, and increasing from 2 to 4. And every one of these numbers is an x value. Never, ever, 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 ever a y value when we're talking about these intervals. All right, and we also use parentheses because at 0, it's changing over from decreasing to constant. And so you wouldn't include it in either one of them. So on these intervals of increasing and decreasing, we're always using parentheses. Okay, so let's look at a couple of examples. Now I'm actually going to change this graph a little bit. So on this A, we're going to draw an extra little line.
Oh yeah, the GPT.
All right, so add that little line, and then we're going to find where the function's increasing, decreasing, or constant. All right, so after we added that line, we're going to start at the left side of the graph, and that arrow is pointing forever to the left. So forever to the left is when the function starts being a function, and when it starts being a function, it is going to be increasing. So forever to the left is -infinity. And we're going to increase until we get to this point right here. And what matters at that point is the x, not the y. So the x, where the function stops increasing, is -5. All right, then we'll go ahead and see if there's another section of the graph where the function is increasing, and there is. So the graph starts increasing again when x is 3. And then we're increasing forever and ever to the right, which is to +infinity. All right, so let's look to see where the function is decreasing. All right, so we need to see the x value where the function starts going downhill. So we start going downhill at this point right here. The x value is 2. And then we decrease until we get to this point right here where the x value is 3. All right, and then for our constant, All right, so the function is constant starting from here to here. And again, we want the x values. So that is from -5 to 2. So try your best to remember that these intervals are only x's, never y's. All right, you guys try to do B on your own real quick. All right, so this function is increasing in this little section right here. And what we care about are the x values, where that function is increasing. So the function is increasing where the x's are between -1 and 1. All right, this function is decreasing this section to this section. All right, and what we care about, again, are the x values. So this function starts decreasing when it becomes a function, which is as far as you can go to the left. As far as you can go to the left is going to be -infinity. All right, and then it's going to be decreasing all the way until you get to -1. All right, and then this function starts decreasing again at 1, and then decreasing forever to the right, and forever to the right is infinity. Again, only x's. All right, the last thing we're going to talk about today, and now this is kind of a long lesson, is the average rate of change. And you guys have done this, but it's been a while. I'm not sure if you did this in Algebra 2 or not. I know you did it in Algebra 1, but it may not have been called this. But to find the average rate of change for a nonlinear graph, you're going to plug points in and find their slope. So average rate of change is just another word or other words to say slope. And so I hope you guys remember the slope formula. On the slope formula, you're going to subtract the y's on the numerator and subtract the x's in the denominator. Or you can think of it as the change in y over the change in x, which is what I usually do. All right, so let's talk about this graph for example 6. We're going to find the average rate of change of this function from x1, which is -1, to x2, which is 3. All right, so this graph is definitely a parabola. So it's going to look something like this. All right, so if we're finding the average rate of change, we're basically, let's see, -1 is here. 3, we'll say 3 is here. I don't know, I'm just guessing. And then we're wanting to find the slope of this line that connects those 2 points. So to do that, we need to find f of -1 from this -1 right here. And we're going to need to find f of 3 from this 3 right here. All right. So to find f of -1, we're just going to plug -1 in for x. So we'll square it multiply it by -2, and then combine our like terms. So this ends up being 1 plus 2, which is 3. All right, same thing here. Square it, multiply it by -2. So they end up getting 9 minus 6, which is also 3. So you guys have options. You can subtract the y's in the numerator and the x's in the denominator. I like to just think about the average rate of change, or the slope, as the change in y over the change in x. So the y changed from 3 to 3. So that's no change. So that's 0. The x changed from -1 to 3. So that isn't increased by 4. So we would do +4 there. So 0 divided by 4 is 0. So that's the average rate of change. I think that's, thinking about the change is the quickest way to do it. If you don't like that, it's not a problem. You just go back and use that slope formula you used to do in Algebra 1. Ooh. Okay, so your assignment comes from the book. So we have page 56 through 58. I want you to do 8 through 24 even, 31 through 35, 37, 61, 62, and 64. And then we'll finish the packet later.